Hello everyone. So it's the very long time that we are meeting in a video lecture, but yeah. So years are the part of our life. We do daily mistakes. Even from morning to this time, you have made some mistakes, little mistakes, or in your life you have made some larger mistakes. So that actually happens in your life. Okay, but what's the good thing is that not to just think about that, okay, I have made some errors. It's just like that, see the errors and improve it. So why I am telling this thing to you? It's just because that AI models also do mistakes that are quite reasonable because we are humans and um, many things with the data that is not very clear. That's why they made mistakes, machine learning models. So, like, let's see what the thing is. Okay, so introduction to the error analysis. Error analysis is crucial step. Like, it is all about that improving the machine learning models. Okay, so we always learn from the mistakes. Uh, in our childhood, there will be there is a process of standing and running. It's just like that. Many of the times we try and we fall, we try and fall, and then again, at a point of time, we become standing and running. So that is the thing, guys. Like, we make mistakes and improve upon it, or we learn from the mistakes and improve it. Okay, so that's what the machine learning does. And like, there is making mistakes and why. So it's important to know that what the mistakes are. Okay, and why they are making it. So in the confusion matrix is the fundamental tool for the error analysis in the classification task, of course. So confusion matrix are a really interesting thing. They make, really, like, confusion matrix has made things very simple. So I am just going to show you something like that. We'll be seeing that. Okay. So what it does? Okay. So let's have a look. Like, what it does, that we are seeing about the MNIST data set. Okay. So MNIST data set is all about 0 to 9, and that is the handwritten. Okay. So that is handwritten digits. Okay. So it classifies. So what a confusion matrix does, that it says you that, okay, 5 was the truth value, but the predicted one was 8, or 9 was truth value, but the predicted was 5, or 6 or 7, something like that. Okay, so let's go and see that what's actually happening, guys. Okay, so this is the book we are, of course, reading. And like, you first need to make predictions using cross val predict. Okay, so you'll be first making the predictions, and then what we'll be doing, we'll be just passing it to the confusion matrix. That is how the confusion matrix works. So let's see very quickly. I have this Colab notebook. This will be in the description. Just go and check it out. Okay, guys. Fine. So let's see. These are some codes. So we'll be seeing it in practical way, that how to do it, and we'll be actually analyzing that what's going on. You can see here, like, in the in between there is a, you can see this is a truth level. Don't be afraid by seeing all these numbers and graphs and all these things. Just be with me. I am going to tell you that what's going on. So just see, this is the truth level and this is predicted one. Okay. So this is the truth level and this is the predicted level. Fine. Now, this is a prediction. So 550, 5577 time, it has predicted 0. But The predicted, but you can see here the 27. Predicted was 27, but the truth was 2. I hope you got. Like 27 time, it predicted 0. Okay, just hold on 1 minute. Okay, so it was predicted 0 at 27 times, but the truth level was 2. Okay, so this is the thing. Like you can see guys, like it has predicted very good numbers in between. You can see here it's all in the 5,000, 6,000, 4,000, in this that. Okay, now you can see here the most interesting thing is that predicted level is 5, but it sees that but the actual true level was 8. So it is somewhat confusing between 5 and 8 because they are seems similar curves, and they have almost one circle is there. That's it. So that is the point, guys. Now you can see here the more mistakes in the 3 also. Like it has predicted 3, but it was sorry, it has predicted 5, but it was 3. The truth level was 3. I hope you have seen this thing. Now we have seen it like row wise, like how the predictions are going on. You can see here 94% it has predicted right. But in 5, you can see here it is 82%. Okay. But the 3% is the error. These are some error values. Okay, guys. These are some error values that we have made some mistakes. So that is the interesting thing, guys. And now we can also see that how it like we have normalized it, okay, by the row, and it was normalized by column. So we have actually normalizing it. So let's see. In the 8, you can see here like 0 is coming very much because 8 is somewhat curved like something like this, and 0 is something like this. So the pixels are just a little change. Okay, so now we are going to see the code, that how it is going to be, and let's see. So we are just no, we have just shrink the whole code into a smaller one because it was taking 10 minutes of the time to run. So it was taking a lot of time because it has a lot of parameters and all these things. But I'm just going to run it, and you can also try it out. Link will be in the description, guys. And okay, so I'm just going to zoom it for you. We have got NumPy, pipe, matplotlib. Then we are actually importing the data set. Then we have the train test split so that we can split the data and cross well prediction, like we are going to predict it. And then SGD classifier is there, that what we are using in this whole classification task. Okay, then standard scalar is there to scale the features, and then we have the confusion mat display from which we are showing this type of displays. Okay, fine. Then we have loaded the data. I hope that's clear to you. And we have loaded only 10,000 data. Okay. So it's like 0 to 10,000 data. Then we have split it in, like we have defined the test size, and it have taken the train size as 0.8, means 80%. Okay, fine. Then we have actually scaled the data. Okay. So we have scaled the data, and we have also put the um, type. Okay. Float 64. And then we are just classifying it. Okay. So we are putting it to iteration, and then tolerance. Then after that we have fitted, and after that we are making the predictions. Guys, this is the predictions. So it now we are converting the string labels to the integers, and then we are going to see something amazing. Let's see. So just wait for it. It is going to show something. Predictions for the first digit. Let's see. And So this was the whole thing, guys. I'll be recommend you to read this book. This is quite interesting, amazing book. Okay. And in this book, you'll be seeing all the things. Okay. So I'm just going to show you this. Like you can see here, like this is five, this is three. But what you call this? This is three or five. This is almost five, but it can be seen as three also. Okay. And you can see this thing. So and this quite similar. So what it is saying that it is very much similar. It seems five now, but it is three. You can see here it is three actually. So what do you tell? So this is a predicted one, but this is predicted five, but it was actually three. Okay, then this was predicted three, but it was actually five. So it made some obvious errors. Of course, we humans understand much more easily things because we have the pre-built mechanism. Maybe God has made, or the creator, whoever made us, very beautifully and complex, so that we can understand in a very easy way. Okay. So SGD classifier is just a linear model. So so that's what it is justifying. Okay, and we can how we can like reduce these errors is just by doing the data augmentation. Guys, data augmentation is very interesting thing because uh, you don't have to do very much things. What is the data augmentation? I just want to show you. Okay, so just hold on 1 minute. I'm just going to say data augmentation. Yeah, what is data augmentation? So you can see here. Okay, maybe this. Yeah, I hope this thing is very clear to you. So it is actually what it is making, that it is from the original image, it is changing its orientation. It is cropping, you can see cropping, blurring, grayscale, darker, noise added, somewhat brighter, horizontal, vertical, 45-degree rotation and all. So it is making the whole, you know, it is making more diversification in the data so that model can learn it more in a more better way. So that is what the data augmentation is. So you can learn it, and we'll be talking about the data augmentation. You can see here in the chapter 14, we'll be covering this. So let's see the code now, guys. So prediction, okay. So it is prediction for the first digit is six. So it has predicted. Okay, just ignore that. Just see in this thing. It have predicted this thing. Okay, it have predicted. Although we have, I think we have taken some small size of data so that it is showing like that. And 96% we are getting the results. And you can say the same thing like this. So this was the thing, guys. I hope you enjoyed this video. You can just go and try this code, that how the code is actually happened in it. From the confusion matrix. Okay, I'm just going to tell you. So from the confusion matrix, you are just passing that white train and white train predict, and it is showing you that okay, this is the thing, guys. Now, what in this thing is the white train predict. We are normalizing it for the true, and value format is 0%. Okay, so this is the thing, guys, and after that. This again is the thing, like sample weight is not equal to white train, and it is showing me. So this was the overall thing. If any doubt, then you can write in the comments. And there are one question in the comments. Go below, try that question. That is quite important for understanding this thing. Okay, and just write in the comments. Okay, guys, thank you so much. And meet you in the next video. We are going to just quickly cover the things very fast. And thank you so much, guys.